On a textile factory floor, a worker reaches too close to a massive fabric calendar machine. The calendar machine, designed to press and smooth sheets of material, is in full operation. Heavy rollers pull fabric continuously through the system. A sheet of material shifts out of alignment, and the worker tries to correct it by hand. As the adjustment begins, the rollers seize the edge of the fabric with sudden force. The moving sheet tightens and accelerates, pulling material rapidly through the system. Within moments, the machinery's motion spirals beyond control, forcing the operation to a halt as the hazard escalates. Never, ever reach into a running calendar or roller machine. The rotating surfaces are unforgiving, and even fabric becomes a powerful trap under their force. A red-hot bar surges off the mill, one looping misfeed, and the whole cooling bed comes alive. Inside a rolling mill, white-pink steel snakes out of the final stand at over 1,000 degrees, laying coils across the slatted bed. Air hisses beneath. The operator below watches, too close to where no one should stand when hot steel is moving. A guide misaligns, sending the bar off track. The buildup of tension causes it to surge and twist across the bed, scattering heat and sparks through the bay. The moment exposes how a single alignment fault can trigger a chain reaction of energy release. Never, ever cross into or stand near the hot bar discharge or cooling bed zone while the mill runs. Distance and exclusion barriers are the only real shield against a live whip of steel. Inside this factory, one worker makes a single move, and the entire workshop changes in a flash. It's a wheel finishing shop. Rows of alloy rims hang in racks, stations lined with bright lamps and vent hoods. In the far right bay, a worker in blue is focused on his task. He grips a spray hose, leaning close to the rack, releasing a burst of coating spray. A cloud drifts upward, shimmering in the light. But the booth's ventilation fails to capture it, and instead, the dust lingers, thickening in the air around him. Comes primed, charged with fine dust. Then, an unseen spark ignites the mix. In an instant, the booth flares bright. Pressure ripples through the room, and the team reacts, hitting the e-stop as smoke and alarm lights fill the bay. Never, ever spray powders or solvents without proper ventilation and ignition controls in place. Dust and vapors don't just hang in the air, they wait for a spark. Test extraction, bond equipment, and keep every ignition source locked out. One overlooked cloud can turn routine work into an explosion. An excavator leans dangerously forward on uneven ground, and what happens next is almost unbelievable. An excavator lurches forward on a work site. The driver feels the machine begin to tilt, the front bucket stretched out too far and throwing off its balance. Instead of staying inside the cab or running to safety, he leaps out, rushing toward the tipping excavator, attempting to stop the fall with his bare hands. The excavator tilts further, its weight shifting beyond recovery. The massive frame rolls forward as gravity takes over, demonstrating how even the smallest imbalance can overpower control. The scene underscores one truth: machines in motion can't be stopped by human strength. Never, ever try to steady or stop falling heavy equipment with your bare hands. The sheer mass and momentum are beyond human control. When hydraulic frames start moving, steel has no resistance. And what happens next shows the danger of standing too close. In the mill, a coil compactor is in operation. Its job is to press and stabilize massive steel coils before strapping them for transport. A worker steps in, too close to the compaction zone. While the cycle continues, the heavy frame begins to move inward, with no pause in its sequence. The jaws clamp as the coil shifts under immense pressure. The machine's frame moves inward with precision, sealing the compacting zone until the process completes. Once the sequence begins, the hydraulic motion is unstoppable. Closing mechanisms in coil compactors create fatal pinch points. Stay clear of compaction zones. Around hydraulic closing machines, safety means distance from every moving frame. It looked like a simple step across, a few planks over an opening, but what happens next will remind every builder why shortcuts never hold weight. High above the ground, on the upper floor of a building still being framed, workers moved quickly to clear debris and collect tools before the next concrete pour. The space was tight and the floor cluttered with rebar, cables, and temporary boards. In the middle of it all, a large open elevator shaft, only covered with a sheet of plywood just to make it easier to move between sides. It wasn't secured, tested, or rated for weight, just balanced loosely between the edges of the concrete frame. A worker walked across to grab a piece of equipment lying on the far side. A few seconds later, he turned to return. As he stepped back onto the plywood sheet, the tone beneath his boots shifted, a creak, then a sudden give. The board flexed and dropped out of place, exposing the open shaft below. In seconds, the scene revealed how temporary covers can't be trusted to support even routine movement. The board failed exactly as designed because it was never built to carry weight. Never ever walk or place any load over an uncovered or temporarily covered opening. A single step on unsecured material can turn stable ground into a deadly void. Inside a production hall, a massive roll of aluminum foil hangs from an overhead crane, and what happens next takes everyone by surprise. A worker in light blue protective coveralls stands near a large plastic film rolling machine. Overhead, a crane lowers a suspended steel roll, weighing several tons, carefully toward its placement cradle. The operation looks routine, the worker watching closely as the roll swings into position. But then, as the crane shifts, the suspended roll drifts out of alignment. The load dips suddenly, grazing the machine frame before rolling off balance. The worker steps back as the massive roll drops free, settling heavily onto the floor and skidding to a stop. The uncontrolled movement of suspended loads creates instant, unpredictable danger zones. Always secure and guide suspended loads with taglines, and never remain in the drop zone. It only takes a few seconds, the time it takes to look away, for balance to disappear completely. On a busy street lined with shop fronts, a small scaffold frame stands beneath a storefront sign. On top of that narrow frame rests an extension ladder, angled upward against the purple shop facade. It's a setup born from improvisation. Ladder feet wedged on a thin platform, no base lock, no stabilizer, no tie-off. At the bottom, a worker in a blue shirt steadies the entire structure with both hands, while the other man climbs up to reach the sign. The man above moves carefully, trusting the one below to keep the base steady. It's teamwork built on instinct, not safety. As the climber reaches for the top of the sign, the man in the blue shirt looks away for just a moment. The frame shifts under uneven weight, the ladder tilts, and the structure begins to sway. Within seconds, balance is gone. The setup reveals exactly how quick stability can fail when human steadiness replaces proper anchorage. Every elevated job needs a structure built for stability, not convenience. Never stack ladders on scaffolds. Each tool is designed for separate loads and angles. Combining them removes both their safety limits. Also, never rely on human steadiness as a substitute for engineered stability. Hands get tired, distracted, or let go. Steel doesn't. He thought the tank was steady, but when the steel beneath him shifted, gravity took over faster than he could react. Inside a fabrication bay, a massive cylindrical storage tank, still unfinished, rests on two temporary cradles. It's not anchored, not braced, just balanced. On top of it, a welder in blue coveralls works carefully, sparks bursting from his torch as he seals a joint seam along the tank's curve. His boots rested on the rounded shell, his ladder set against the side for access, his fall arrest line clipped overhead to a crane hook, the only thing between him and the floor below. Everything seemed stable until it wasn't. The tank shifts slightly on its cradle, a few inches that change everything. The welder's footing slips across the curved surface, his torch flickers out, and tension ripples through the overhead line. The setup reveals how even minor movement on unanchored steel can turn balance into a moment of recovery. Always secure round or cylindrical vessels before climbing or welding on them. Use certified chocks, wedges, or cradle mounts. The hazard begins the moment you treat a curved, unanchored object as stable footing. High above a warehouse floor, a worker balances on a stack of boxes. One wrong shift, and the entire structure betrays him. It's a typical loading operation. Forklifts bring in heavy pallets of boxed goods, and workers climb onto the stacks to help arrange them by hand. The stacks are already several meters tall, rising like makeshift platforms in the center of the warehouse. One worker, shirtless in the humid heat, steps onto the uneven pile to guide and reposition the newly added load. As the worker shifts his footing on the narrow forks, the load wobbles beneath him. The sudden movement breaks his balance, forcing him to steady himself mid-air. With no guardrails or harness, the instability turns the stacked pallets into a fall hazard. Standing on forklift forks creates a false sense of stability. They are not work platforms, and a single misstep transforms them into a fall hazard. Always use proper fall protection systems or man lifts when working at height. Forklifts move materials, not people. In a die casting plant, a worker steps in to inspect a running machine. And what happens next shows the unforgiving power of automation. Inside the factory floor, with massive die casting machines clamped shut with hydraulic force, a worker steps in close, examining the area, while the automated system is still active unknown to him. Without warning, one of the robotic arms sweeps across the active zone with full mechanical power. The automated die casting line continues its cycle, clamping and shifting with hydraulic precision, unaware of anything within its path. The moment reveals how automation, once engaged, moves with unstoppable momentum. The danger lies in active die casting cells. Robotic arms and hydraulic clamps operate with immense speed and crushing force. Always lock out and tag out before you inspect. Deactivate before you investigate. A worker crosses the yard, unaware a truck is bearing down, and what happens next shows how one wrong approach can turn deadly in seconds. This is a steel yard, where sheets and plates are stacked in tight rows. A red semi-truck suddenly advances, rolling directly into the same narrow path where a worker is walking. In an instant, the truck advances through the yard, veering into the narrow lane beside the stacked steel. The space tightens quickly, transforming what seemed like a routine path into a confined danger zone. The danger emerges when moving vehicles and foot traffic share the same confined workspace. A blind spot, a turn, or a sudden advance can create a crushing trap. Vehicles and pedestrians cannot mix freely in industrial yards. Clear walkways, stop signals, and strict separation are the only safe approach. He was just walking past the tank when it happened. And what came loose changed everything in seconds. A worker in a blue uniform and hairnet walks casually through the narrow aisle of a food processing plant, just past one of the heating tank systems. The floor is clean, the shift calm, the noise steady, pumps humming, valves clicking. Nothing feels out of place. Without warning, a pressurized hose connected to one of the hot water tanks snaps free from its fitting. Steam bursts outward, filling the aisle as the hose whips loose and spins across the floor. Alarms sound as the area floods with vapor, a sudden reminder of how pressure doesn't wait for a second chance. Never, ever leave a pressurized line without a proper mechanical clamp or locking connector. Heat and pressure will always find the weakest point, and when they do, they don't wait for anyone to be ready. In a chemical plant, one wrong move against a pressurized valve unleashes a surge of hidden force. A worker grips a long bar, struggling against the tight seal of a valve cover. Nearby, his supervisor watches on, unknown to them, the pressure inside the system building silently, hidden from view. With one final pull, the cover loosens, releasing a sudden wave of pressure. Steam and vapor burst outward in a rush, spreading through the confined space. The release turns the calm workspace into a high-pressure hazard zone in seconds. Never, ever attempt to force open a pressurized system without fully isolating and relieving the pressure first. Hidden energy inside vessels and pipelines can release suddenly, and the results are catastrophic. Workers mount on top of a gas tanker going about their activities, and suddenly, the next few seconds change everything. Two workers stand on the dome of a gas tanker, checking fittings near a pressure line. Around them, a network of pipelines and valves threads through the structure, all gleaming with the precision of a system built for efficiency. One of them steps back to adjust a valve as vapor drifts unseen through the air, forming a fragile envelope of danger waiting for a trigger. In an instant, invisible vapor finds its ignition point. A flash ripples across the tanker's crown as pressure vents outward, lighting the scene in a brief, blinding burst. The scaffolding vibrates, alarms echo, and the calm gives way to a wave of heat and sound. Every tanker carries two hazards: the fuel it holds and the vapor it breathes. Gas vapors are silent and invisible, yet their power is instant and absolute. Always vent, ground, and test before opening a fuel line. You can't see vapor, but it can see your next move. Inside a machine shop in Tatarstan, one routine task near a lathe turned into a deadly chain reaction. It's November 19th, 2020. A 56-year-old worker named Murat was at his station operating a DIP 300 lathe. He's not in protective gear. The long sleeves he wears hang loose near the moving parts of the lathe. Murat leans closer to make a quick adjustment. Without warning, the lathe's rotation surges to life. His loose sleeve flutters near the spinning part, a moment's lapse that turns routine maintenance into chaos. The machine hums to a stop seconds later, a stark reminder that energy never waits for hesitation. Never, ever work near a lathe or rotating equipment without proper clothing and lockout. Always stand clear of the rotation zone and disconnect power before making manual adjustments. On a quiet city morning, a single tire breaks free, and what happens next catches everyone off guard. Outside a small storefront, a security guard stands near the entrance, casually chatting with a passerby. The street hums with normal traffic, scooters, delivery vans, and the distant buzz of engines. Everything feels routine until a tire, detached from a moving vehicle farther up the road, suddenly breaks loose. It spins violently, bouncing off the pavement, gaining speed, and ricocheting unpredictably toward the sidewalk. The runaway tire barrels toward the storefront, striking the entrance frame with a heavy thud. Shards of debris scatter, alarms echo, and bystanders scramble for cover. In seconds, calm turns to confusion. No one is sure where it came from or where it'll stop next. Never, ever overlook vehicle inspection, especially tire mounting and wheel assembly. A single loose lug nut or neglected maintenance check can turn a harmless component into a projectile capable of immense force. Every driver, fleet operator, and mechanic must understand that kinetic energy doesn't forgive neglect. Tire integrity and fastener torque checks aren't optional. They're life-saving habits that prevent roadside hazards from reaching the unsuspecting. In a deep, unstable trench, one wrong second turns the earth itself into the biggest danger. A lone worker moves through the freshly cut soil, the walls towering over him. The ground looks solid, but the weight of the earth above is deceptive. Every vibration, every shift carries the risk of collapse. Suddenly, the trench wall gives way. Soil and clay rush downward, filling the space in seconds. The collapse shows how quickly unsupported earth can give way under its own weight. Never ever enter an unprotected trench deeper than chest height without proper shoring, shielding, or benching. A delivery truck reverses into a narrow street. Then, in the span of seconds, two separate accidents unfold back to back. A delivery truck creeps backward toward a shaded corner wrapped in blue tarp. The alley is so tight that even a minor misstep could spell chaos. The driver, relying solely on mirrors, inches back without a spotter. Behind him, another worker is positioned inside, unaware of what's about to unfold. The truck reverses too far. Its rear corner clips the tarp frame, sending poles and fabric tumbling down. Startled, the driver shifts forward, shaking the truck as the unsecured rear door swings open. A worker near the edge loses footing in the motion, regaining balance just as the vehicle settles. Two separate jolts seconds apart, proof of how small oversights can stack into one dangerous chain. Never, ever reverse or move a vehicle in confined spaces without a spotter and full communication. Never assume the area or the back of your truck is clear. One unverified move can double the risk before you even touch the brakes. On a truck bed, tall stacks of glass sheets stand upright until one shift sends them crashing down. A worker stands beside the unsecured load, the glass held only by its balance. With no braces or straps, the towering sheets remain dangerously unstable. As he moves along the side, the balance shifts. One stack begins to lean, setting off a chain reaction among the others. In moments, the unsecured sheets give way, scattering across the ground, a full collapse triggered by a single unstable point. Unsecured glass sheets create a high-risk hazard. Once balance is lost, breakage is inevitable. Always restrain, block, or secure glass loads before anyone works near them. Stability must be guaranteed before safety can be assumed. A simple wall cut on a sunny balcony. But what happens next shows how one slip of a spinning blade can turn control into chaos. On a narrow apartment balcony, a worker is using a handheld wall cutting saw to carve a vertical line into a reinforced concrete wall clad with small ceramic tiles. To him, this is just routine work, opening a channel for conduit installation, but every condition here is primed for risk. A confined workspace, a wet floor, no grounding protection, and a tool that reacts faster than human reflex. As the saw cuts deeper, the tone shifts. Resistance builds until the blade catches rebar hidden beneath the tile. The tool reacts instantly, its torque reversing in a sharp kickback. The sudden motion throws mud and dust into the air, and the saw spins briefly before powering down. In moments, routine work turns into a lesson on how torque and traction collide. Never, ever cut into concrete or tile without knowing what lies beneath, and never stand in the line of the blade's recoil. When torque reacts, it doesn't wait for you to move. It looks like a routine weld, a few sparks, a steady flame, but what happens next turns calm steel into a sudden blast. Inside a small repair workshop, a welder is working near an upright metal drum. He positions his torch near the top seam to seal a small leak. No smell of danger, no smoke, just another quick job before the day ends. But inside that closed drum lingers a mix of oil vapors and compressed air, an invisible trap of flammable gases. As the torch touches the drum's surface, the trapped vapors ignite, releasing a burst of pressure that lights up the workspace. The reaction is over in a second, a stark reminder of how sealed containers can turn residual fumes into sudden, uncontrolled force. A worker pours paint thinner onto an open flame in the corner of the shop. And what happens next changes everything. Inside a fabrication shop, stacks of aluminum profiles line the walls. Machines sit silent, and workers move about. But in the far corner, one man stands with a can of paint thinner in hand, pouring it over flames in a misguided attempt to keep the fire burning. What begins as a flicker quickly turns volatile in this confined industrial space. The moment the solvent touches the flame, the reaction is immediate. Vapors ignite, and the fire surges upward, spreading across nearby surfaces. What began as a controlled burn now flashes into uncontrolled heat and light, filling the space in seconds. This is why flammable liquids must never be used to fuel or sustain fire. They turn a small flame into a violent flashover. Store them safely, handle them with caution, and keep ignition sources far away. In a workshop filled with towering tanks and silent heat, something unnoticed begins to build beneath the surface. At a magnesium plant in Russia, maintenance crews were inspecting a furnace unit used for titanium and rare metal recovery. Around them, massive vertical tanks rise from the floor, each containing volatile magnesium compounds and titanium chlorides. A reaction begins deep within the separation unit, a faint spark inside the furnace chamber. In moments, the glow intensifies. Light floods the workspace, and the air ripples with radiant heat. The system shuts down as magnesium ignites inside the vessel, sending bursts of light and vaporized metal upward. Reactive metals like magnesium and titanium can ignite explosively when exposed to air, moisture, or improper cleaning during furnace inspection. Every maintenance procedure in such environments must follow inert gas purging, surface cooling, and strict ignition control before any inspection begins. One loose sheet, one small step, and the roof gave way without warning. At a residential construction site, a lone roofer was fastening corrugated metal sheets above a workshop extension. The afternoon sun glared off the steel, and the sound of his drill echoed through the frame. He crouched near the edge, securing a panel, then shifted across to grab screws from a plastic bag, his footing unsteady on the smooth metal surface. As he stepped onto the adjoining sheet, the panel flexed, its unsecured edge sliding free from the frame. In an instant, the section dropped, exposing the space below as metal clattered against the beams. The sudden shift sent vibrations through the frame, a clear warning of what happens when temporary surfaces are mistaken for solid ground. Temporary placements without anchors or clamps turn working surfaces into fall hazards waiting to happen. Every sheet on a roof is either fastened or forbidden to step on. Use roof brackets, guardrails, and fall protection whenever the frame is incomplete. Always verify anchorage before trusting your footing, because the surface that looks firm might be the one that gives way next. Inside a concrete shaft, a worker tugs at a heavy panel. Then, in a split second, gravity answers faster than he expects. It's a typical construction zone: damp floor, scaffolding frames, and towering concrete form panels leaning against the wall. One worker, standing in the narrow space, grips a crowbar to pry loose a large form that looks jammed in place. There's no tagline, no bracing, and no one spotting from a safe distance. Just one man and a wall of weight balanced on edge. With one pull, the form finally gives way. Instead of easing outward, it tips forward under its own weight, landing hard as dust and vibration ripple through the shaft. The worker steps back, startled by how quickly balance turned to freefall, a reminder that gravity doesn't give second chances. A single concrete form can weigh hundreds of kilograms. Once its center of gravity shifts, there's no stopping it. Never free heavy formwork, manually or alone. Use taglines, wedges, or lifting gear to control direction and descent. Unsecured panels are silent hazards, waiting for the moment someone pulls from the wrong angle. It looked like a simple highway maintenance stop until one car crossed the cones and everything ahead vanished in an instant. Early morning on an open expressway, traffic flowed at full speed. Sedans, vans, and white utility vehicles moving in steady rhythm. On the left lane shoulder, a small road maintenance pickup is parked with its hazard lights on, towing a trailer-mounted aero board flashing bright yellow chevrons. Around it, two workers in reflective vests move cones into place, creating a taper to divert traffic around the shoulder. But this isn't a closed lane, just a small temporary patch zone without barriers, without an attenuator truck, and without a full buffer distance. The crew relies solely on drivers seeing the lights, understanding the cones, and reacting in time. A gray sedan approaches from behind, its speed steady in the inner lane. For a moment, it tracks straight, then drifts slightly, cutting through the cone line. With no barrier truck or buffer zone in place, there's no margin for correction. In seconds, momentum carries through the work zone, proving how a single oversight in protection can turn space into exposure. Never, ever set up a live lane maintenance zone without a physical protection system. Cones and lights are not shields. Only separation, distance, and barriers stop kinetic energy from turning a work zone into an impact zone. What happens when precision meets carelessness, and one wrong reach turns the machine into a trap? Inside a heavy machine shop, a vertical turret lathe dominates the space. A steel giant with a rotating table over 2 meters wide, built to handle massive components. The operator climbs onto the lathe's table just to reach the overhead control pendant. Down below, his colleague watches casually, assuming the machine is isolated. Then, in a heartbeat, the VTL table activates. The rotation surges with full torque. The operator's stance breaks as the polished surface turns beneath him. The motion exposes just how fast stored power can react when isolation isn't complete. A single live circuit turning balance into chaos. A vertical turret lathe is not a platform. It's a live, powered work zone with rotational energy that can activate without warning. Do not stand, sit, or reach across a VTL table for any reason. Instead, isolate power completely, lock out, and position control pendants within reach from the floor or a stable platform. He walked beside the furnace tracks, unaware that above him, a mountain of metal was already letting go. In front of the blast furnace line, a diesel locomotive assistant walks the rail path, checking coupling lines. Above, the slag bay holds tons of compressed metal shavings, stacked and unstable, dried under furnace heat. Everything looks routine. Then the vibration of the moving locomotive shakes the side of the pile. Without warning, the pile shifts. A wave of metallic dust and shavings slides downward, covering the rail track in seconds. Visibility drops to zero as heat and vibration trigger a chain reaction of movement, proof that even a stable surface can turn active without a sound. Never ever walk beneath or beside a loaded slag or scrap pile without verified stability clearance. Do not assume stillness means safety. Dust clouds can hide movement until it's too late. A pile doesn't have to move fast to be deadly. It only needs to move once. Weight, heat, and vibration don't mix. Respect the pile. Keep your distance. He climbed onto his truck for what should have been a quick adjustment, but what happened next turned a routine moment into a silent, unseen danger. A delivery truck stands parked under a loading bay roof. The driver alone climbs onto the cargo bed to fix the tarpaulin covering his load. He's focused on securing the tarp, unaware that his next movement will bridge the invisible gap between safety and high voltage. As he tightens the tarp ropes, he unknowingly steps beneath a live power line. In that instant, the air hums. An invisible arc flickers between metal and voltage. A sudden flash lights the scene, and the truck hums with the reminder that electricity doesn't always need contact to strike. Electricity doesn't wait for marked contact, it reaches out. High-voltage arcs can travel through air, metal, or even moisture, grounding through anything nearby. Always survey overhead clearances before climbing on trucks or trailers. Maintain at least 10 feet of distance from power lines, and never use metal tools or bars near them. A few seconds of awareness can stop a fatal chain of contact before it begins. Don't forget to share what you learned today in the comments. Your insight could save a life. Take care.